Hi, my name is Horich, and I'm actually doing this for a pre-calculus class, and this is a study guide for a summer term. And off the study guide is page 560, number 3, and number 7. I picked the following two. Some students don't know if they have something set equals to 0, how to go about doing it, if they want to substitute. So this is two-line. We're doing this solve by substitution. Two-line, we either solve for x or solve for y. It's best to solve for y here because we don't have to divide by 4. It's best to solve for y here because we don't have to divide by 8. This is the hyperbola in a line. And basically what you're trying to do is to look for where the line run into the hyperbola and touch each other at where they run into each other. And so it's this one, where those two lines run into each other. And we're going to try to figure it by algebraically. Before we can do this, we need to put down what we actually doing. We can't just start writing. What we want to do is that we want to say state and say, okay, let me substitute equation 1 for y, or let's not substitute, but solve equation 1 for y, or solve equation 2 for y. So I'll say solve, we'll go with equation 2. We'll say solve equation 2 for y. And that gives us an idea, whoever's watching your work, you're prompting them what you're about to do. So we'll have 8x plus y minus 17 equal to 0. If I solve for y, all I have to do is say minus 8 minus 8x. And I'll have y minus 17 equals to minus 8x. And then we'll solve this for y, and so y would equal plus 17 on both sides. And that will go away, so you have y equal minus 8x plus 17. And then we can call this equation, let's call this equation number 3. Number 2 is the same thing as number 3, but you arrange this for y. And this was everything on the left and set equals to 0. They look different. So if we have something that looks different, we want to keep track. We want to call it number 3. And we can use this now. If we solve 2 for y, we can put this one, which is the new 2, which is 3, we can put it back into 1. So we'll say substitute. We'll abbreviate this. We'll substitute equation 3 into equation 1. By doing this, we'll have 4x minus, if you're subtracting, you want to put both terms inside if you're subtracting. But if it was plus, it really didn't matter. It really doesn't matter. You just want to make sure that that minus gets distributed by both of these terms that you're going to substitute for y. So that's going to be minus 8x plus 17. And then follows, because that was minus y, in place of y, you're going to put minus 8 plus 17, minus 1. And then set that equal to 0. You will have 4x, that will give you plus 8x, minus 17 minus 1 equal to 0. Here you'll have 12x combined like term, and this will be minus 18 equal to 0. Move the 18 on the other side, plus 18, 12x equal to 18. So x equal to 18 over 12. And when you simplify that, x equals to the 3/2. Divide top and bottom by 6. X equals to 3/2. Now we're going to put this, we can call this 4 if you like, just to keep track. And now we can say that we're going to substitute 4. And where you want to put it? You want to put it to the equation that you solve for y. Here's the equation that we solve for y, which is equation 3. What we'll do is we're going to substitute this into here. And that will be easier to just evaluate for y. And we'll say we'll substitute 4. Substitute equation equation 4 into equation 3. Once we do that, we'll have y equal minus 8, parenthesis, 3/2, and then we'll add 17. 2 goes into 8, minus 4 because it's minus 8. So minus 4 times 3 will get negative 12. So y equal negative 12 plus 17, and that will give you y equals 5. So when x equal 3/2, we have, when x equal 3/2, comma, then we'll have 5 for the y value. When you actually plug this in, you would find 3/2, 3/2, 4 times 3/2, 8 times 3/2, minus 5, plus 5, minus 1, minus 17. When you evaluate all this side will equal to 0. When you evaluate all this side will equal to 0. If both of them come out to be each side equal to each other, then you can say, okay, this point is a solution set to my answer. Then you can put it in a curly bracket as a set. Now for this equation, what we'll do is best to solve for x or solve for y here, because then that way I don't have to have square root in my expression. What I will do is to solve, before I start, I'll say solve, since x here is positive, I'll say solve x for equation, solve for x, solve equation 2 for x. Then I'll have the following, x minus y equals to 1. Solve for x, x would equals to 1 minus y. Or I can just say x equals to y, plus 1. That equation we can call it 3, just to keep track. Now I can substitute 3 into equation, substitute, I can just make a little notation like this, and I'll say substitute 3 into equation 1. Then I'll have the following. If x is y plus 1, everywhere I find x, I'm going to put y plus 1. So in this case, x is here squared, I'll say y plus 1 squared minus y squared equal to 9. Then I'll FOIL this. I'll have, when you FOIL this, when you say y plus 1 times y plus 1, you FOIL it, you'll have y squared plus 2y plus 1 minus y squared equal to 9. Those two cancel each other. If they didn't cancel each other, you would subtract 9, bring everything on one side, and then have the quadratic set it equals to 0, where you have, same way where you have ax squared plus bx plus c equals 0. So in this case, those two cancel each other, so you end up with just y. We'll put numbers on one side and variable on the other side. So in this case, I'll have 2y plus 1 equals to 9, minus 1 minus 1. So basically, minus 1 on both sides, I'll have 2y equals to 8. Y equal to 4. I can call this 4 if you like, just to keep track of everything. So I'll say I'm going to plug in 4. Plug in 4, this, you can plug it into here, but you're going to end up with just one answer. What you want to do is to plug it back into this. If you plug it back into this, you'll come out with 2 x's and 2 y. Then you need to try those 2 x's and 2 y to see which one that worked. Let's plug number 4 back into number 1. We'll have, for y, we'll put y in. Here we'll say we'll put 4, equation 4 into equation 1. That will give us x squared minus 4 squared equal to 9. That will give us x squared minus 16 equal to 9. Add 16 on both sides. X squared equals to 25. X equals to plus or minus 5. X equals to plus or minus 5. That means I have two order pair. When I put 4 for y, okay, I have two x's. That means that I have two order pairs. When I put 4 for y, that means y will be 4. I have minus 5 and I have plus 5. You want to check those answers? If I put minus 5 in, I square minus 5. I get 25. I square 4. It'll give me minus 16. So minus 25 minus 16, that checks. It gives me 9. But let's try to see if it worked down here. If I put minus 5 and minus 4, minus 5 and minus 4 does not give me 1. So far, this one does not work with both of them. Let's try 5 and 4. I put 5 here, I get 25. Minus 4 squared, that would give me 16. 25 minus 16 gives me 9. Let's try it in the second one. 5 minus 4 gives me 1. So therefore, this one is the answer. We'll put this in a curly bracket. So it's important to check your answer when you get your solution and make sure they work before you give that as a final solution. Hope solve by substitution helped this video, and we'll come back with some additional video that I'll pick that I'm aware that I feel like it's necessary for the student to know, and I'll work them out. I'll see you guys in the next video.